Hello, this is Gautam Beg and welcome to a presentation for Industry 4.0 and Cybersecurity System. During this presentation, we are going to look at our system through a sketch, and then we'll look into tools and software used for developing the system in methods, and then we'll demonstrate the system and see the results and analysis of the result. And at the end, we'll go through the cyber security aspect of the system in discussion. So this is the system which is being developed, and control application in LabVIEW was developed to control the air heater process, both the real air heater model and air heater simulator in form of discrete equations were implemented in LabVIEW control application in Formula Node. And there is another LabVIEW application, database application, which fetches the data from a control application and store into SQLDB. And communication between these two applications are on OPC server. Then by using Visual Studio and ASP.NET Core, and local application is developed to get the data from local SQL DB, which used the local SQL server, and display the data over web interface. When all the system is developed and tested, then the system is deployed on Azure Cloud by the means of declaring a database and SQL Server on Azure Cloud, and synchronizing this SQL database with the local SQL Server management, and then deploy a whole system as a web app on Azure Cloud. Materials and software used in developing the system are air heater model for testing, PC software is Windows-based PC, Windows, LabVIEW, latest 2023, 2022 Q3, SQL Server Management Studio, Visual Studio, Azure Cloud, and in Azure Cloud we have used SQL Server and app services. And for frequency analysis of a control system, Spyre Python were used. Frequency response and stability analysis is a tool for, this is the method and tool which is used to see the behavior of a control system. And this is available in Python, library for performing frequency analysis or frequency analysis and stability analysis of a control system in Python via control lib. And that's what we have done here. I've combined transfer functions for heater process, air heater process, and then use control.paid function for introducing the delay in our air heater process transfer function, and then transfer function of PA controller, transfer function of measurement sensor, transfer function of low pass filter, and at the end took all these transfer functions in series and created a loop transfer function. And then we are able to perform frequency analysis by plotting the baud plot, control.baud, and also poles and zero diagram, and gain margin and phase margin calculations with control.margin function. So here are the results for our system. We can see that here is the gain margin. Margin we can use to, or we can increase our KP gain too. And this is our phase margin. So over here is the control dot margin function is giving us the values WC 0.13 radian, 13 radian, and W180 0.21. Here our frequency WC is less than 0.31, and here is the critical gain 0.31, and our gain in settings here is 0.1, which is less than critical gain for now. So that's why our system is behaving asymptotically stable, and this can also be confirmed with this poles and zero diagram, that all the real poles are on the negative side. So our system is asymptotically stable. Then we'll demonstrate the system and look at the results. Here are the applications for this is the control application, and this is the OPC server, and this is database application, which reads the data from a control application and writes to SQL database. And if we look into this, so here are filter, PA controller, and air heater simulator transfer functions, or discrete equations are implemented in formula node in Euler form. So we are simply taking the set point, temperature set point, and PA controller is controlling the temperature, and here air heater is giving or calculating the temperature, simulating the temperature, and feeding it back to PA controller as a PV. And then we are writing we are using this OPC client write sub VI. If we look into it, so it is OPC write client, which takes data and write to OPC server, and this is developed using OPC UA toolkit and LabVIEW. Then here is the server, which is also developed using OPC UA toolkit. It's a simple, straightforward implementation of OPC server using OPC UA toolkit. And then our database application is receiving the data from control application and formatting SQL query and writing the data in our SQL database. Here it receives the data from OPC read client, also made out of OPC UA toolkit. And formatting SQL query and writing into our database. So let's run OPC server, and let's run this control application, and let us look into our database. This is the local database, and here are a few entries into it. So let's run our application. I'm increasing this set point. So here, if I refresh, so here are new values written into our database. Then we actually using ASP.NET Core application. I've developed this .NET application to fetch the data from our local database here. And we have programmed it using also Razor syntax, this application page. And here is the main model, and if we run this, so for some reason it's there. So this is data fetched from our database. And then when the system is working, we have deployed this whole system on Microsoft Azure. Here, this web app IoT is published from Visual Studio. Here is the measurement database, which is defined here in Azure, and there is a SQL Server defined in Microsoft Azure. And if we go back to Microsoft SQL Server Management Studio, so here is the server from cloud which is connected, and here is the database or table, databases and table, and this is connected towards Azure Cloud. And then we have implemented or published the same application here in Azure. And this is here we can see this is coming from Azure and not from our local Visual Studio. So here is the same app which is deployed in Azure Cloud. So at the end, we will discuss some cybersecurity aspects of the system. The biggest challenge or security threat when working with SQL databases is SQL injection issue, which is like SQL queries can be entered into your database and through input forms or input fields from web application, and this can destroy or sabotage your databases. And to protect a website from or your application from SQL injection, you can use SQL parameters, which are values that are added to an SQL query at execution time in controlled manner, and also use SQL authentication. Implement security structure in your database and do not use standard admin account, and define the privileges and access to your SQL users. Database and servers in Azure are protected by firewalls. Implement user-specific firewall rules for enhanced security, just like I did for my SQL server and database access in Azure. Now, firewall rule is set that only my PC or my SQL Server Management Studio can access a database on Azure Cloud. So thank you.